Assalamualaikum. Very good day to all of you. So today we will continue our lecture regarding the split unit system. So by last week we have go through some important things that and the fundamental studies of the split unit system, and on the refrigerant side, and then the impact of the refrigerant towards the environment. So before we go to the deeply to the bigger or centralized system, let me go through to the procedure and tool for the installation of the split unit system. I believe you guys have done the basic installation, the copper fitting, the flaring during the fundamental HVAC subject. So this is just a brief introduction on the maintenance sides and on the installation and maintenance sides of the installation. So some item that we need to be look into it, which is the caution item, which is the piping. So on the thickness, the flaring, the contaminant and the moisture, the vacuum, which is the tool to use for the adapter during the vacuum, and then the manifold gauge, and then during the recharge or charging process. So in this slide, there are several items that we need to use for the installation. For example, the manifold gauge, of course the manifold gauge for split unit system, and then the charging hose, the gas retention valve, and then the pump adapter, the flaring tool, and then the digital balance to weigh how much the refrigerant that we have already charged to our system, and then the PRD checker, and also the tachometer to read our RPM. And then on this slide, it shows the connecting pipe and the flaring process for the pipe. So as you can see on the left hand side of the table, which is the nominal diameter, we have 1/4 inch, 3/8, half inch, and then 5/8, depending on the size of our how much horsepower of our split unit system. And then this is the outer diameter, is referred to our copper pipe here. 6.35 millimeter is referring to the 1/4 inch diameter of copper pipe. Then we have also the pipe thickness. As you can see, 1/4 until 1/2 is equal to 0.8 millimeter thickness, and meanwhile 5/8 size is about 1 millimeter thickness. So basically, as you can see on our right hand side, we have about two type of flaring type, which is the clutch type and then wing nut type. As you can see here, there are two type of refrigerant used, which is the R22 and R410A here. So the A is referring here is for the how much the depth of our flaring that we need to do. For example, for 3/8 here, 3/8 for R410A, for example, we need to have about 1 to 1.5 millimeter area to make sure it cover the nut here, to make sure we doesn't have the leakage there. But somehow if we are using the wing nut type, we need about 1.5 to 2 millimeter of A of the flaring size. So usually for R410A, the copper pipe thickness is usually will be more than 0.8 millimeter due to the high pressure of the refrigerant. So basically, this is the correct way and the correct size of the flaring process. Same goes to this side, but this is on the flaring dimension. So this is the copper pipe size here, and then the outer diameter is here. So flaring diameter of A here is, for example, for R22 is about 9 millimeter here, and then but for R410A it must be bigger, 0.1 millimeter here. And then the flaring nut size also almost the same for all, except for half millimeter, which is 24 and 26 millimeter. And then 5/8 is 27 and 29 millimeter here. So this is the correct value. Basically, I know during the flaring process, we are usually using our agak-agak type, which is the almost size that we can see using the flaring nut. But somehow this is the direction or guideline that supplied from the manufacturer, which is for the flaring dimension. So we need to have this guideline to make sure we give a good practice to our technician on how much of the flaring diameter, how much of the flaring nut size, depending on the copper pipe diameter and the size of our split unit system. So basically, this is the example of the picture when we are doing the flaring. So this is after we do the flare forming. So as you can see here, the pipe thickness still thick, and then after we tightening the nut to the service valve, as you can see here, the thickness of the copper pipe will be reduced. So somehow this is the example of the copper pipe that coming into the nut and the service valve. So this is the example of the wrong. I cannot say it is wrong, but somehow it is not properly flare because it will go. It will makes there is small leakage here because the flaring is not fully covered to the nut here over here. So if we are correctly forming a flare, as you can see here for the flaring dimension, it is not exactly become thin compared to previous one. So as you can see here, this is after the flare forming, and then this is after the tightening nut to the service valve. Is still the thickness of the copper pipe is not much more different compared to before we tightening it. So when we put the copper pipe into the service valve and the nut, it will correctly put into the service valve, and then there is no possible of small leakage of refrigerant will go through the our flare of the copper pipe here. So we can say it is a very good practice here. For this slide, we shows on the correct way on the when we are handling the copper pipe. For example, we have to make sure we avoid the moisture or humid air that coming into our copper pipe, because the contaminant of the humidity will be mixed to the refrigerant and will be disturb our refrigerant cycle. And then we have to make sure we conduct a proper air purging by vacuum process to make sure we have a very clean our refrigerant cycle there. So that's why we must properly do the vacuum process, and then that's why we recommend to use the vacuum adapter to avoid all backflush to coming into our refrigerant cycle. So if you are handling the copper pipe or the installation process during the rain, you have to make sure you cover up here on your end of your copper pipe here by maybe, for example, or using plastic bag. So in industry, maybe somehow after they are doing they are cut the copper pipe, they will sellotape it using the black tape, for example. So this is very important things. And then when you are handling the copper pipe, at the end of the copper pipe you have to make sure you are not near to the ground, because the dirt or the dust from the ground will enter to your refrigerant cycle and enter from the copper pipe there. And then when you are doing, after you are cut the copper pipe, you have to make sure you are doing the dabbering process, but somehow you have to make sure you are uh, uh, send pipe end to the downward process to make sure the dust or the dirt from the dabbering process goes to the ground. And then when you are this is quite common process when you want to to go through pipe to the wall. You have to make sure you cover up using plastic or black tape, cover it completely, because the dirt or the dust from the wall will make sure coming into your system or your copper pipe, because of you have already drilled the wall, and then the dirt is too many here and it will go coming to your copper pipe here. So this is quite important when you are get your split unit aircon from the manufacturer or supplier, for example, during the installation process. You have to make sure you properly bend the pipe from the split unit or your indoor unit. So you have to, for example, this is the step: lift up the pipe slightly, and then hold bend area with one hand, and then slowly bend the pipe downward, and then hold the bending area with one hand, because you want to make sure there are no uh, um, cement there, because the refrigerant will not fully go through the cycle. Not the flow rate of the refrigerant will be not going it completely. So that's why you have to make sure slowly bend the pipe, and then always keep one hand holding at the bend portion, because you doesn't want to make sure there is crack from the copper pipe at the indoor unit, because this is quite dangerous, because usually this indoor unit will become complete with the copper pipe here. So this is the example that I say before. If you are not properly bend the pipe, so it will make sure, for example, if the pipe diameter is reduced to less than 2/3, so the flow rate of the refrigerant will be affected, and then you will not have the a very correct flow rate in your refrigerant cycle. So this is the example of one wrong copper pipe bending, and then this is quite acceptable, but actually this is the way you should make sure the diameter is always maintained from early to the end of the copper pipe. So you have to make sure you use a very correct bending equipment. So for the vacuum process, you can use any conventional vacuum pump. So this is quite easy to find it, the vacuum pump in the market. So the manifold gauge also, if you are using for the R410A, you never use the R22 manifold gauge to avoid contaminant. But somehow nowadays, we can have the manifold gauge for both, for R22 and for R410A, and this is they highly recommend to use the vacuum pump adapter to make sure to avoid or black flush to the refrigerant cycle. So basically this is the process of vacuum process. Remove the cap nut. So as you can see, you can read from A to K here. Basically this is the easiest way of the vacuum process. But somehow if you really want to feel the vacuum process, I don't know whether you guys have done it in fundamental HVAC subject, but somehow for maintenance of split unit system, we have to do the vacuum process. So please make sure you are familiar with the vacuum process here, and then maybe we will do in the lab exercise.